All right, my friends, let's see how it goes. So keep in mind this definition of what component form is. And you'll know we're using component form when they use these cute little brackets that we're using here. So when you see that vector u has component form 3, -2, that means that the point 3, -2 is simply its terminal point. And all component form vectors would start at the origin. There we go. And make sure you label next to the vector, make sure you label it as vector u, since we're going to put a second vector on the same plane as well. Okay, don't forget its little hat there. Okay, vector v, my friends, let's see, that has a terminal point -1, 5. And it starts at the origin as well. There we go. And we'll label that with vector v. Okay, so we graphed both of those. And then now for, what is vector u plus vector v? So really you're just going to take 3, -2, and you're going to add it to -1, 5. And I bet if you just kind of threw something at it, you probably landed right on it. So to add two vectors in component form, you just add the x components. So you do 3 plus -1, and that becomes your new x component. And then you add your y components, and then that becomes your resulting y component. So hopefully it makes sense that your answer would be 2, 3. There we go. Okay, now some vocabulary for you. When you're asked for what's called the resultant vector, that's simply what you get when you add two vectors together. So in this case, the resultant vector of vector u with component form 3, -2, and vector v with component forms -1, 5 would be the 2, 3. So hopefully that makes sense. Okay, now before we move on, let's actually plot on the same plane. Let's plot this resultant vector. So 2, 3. Let's show you something super cute. So here we've got, this would be vector u plus vector v here. And then there's something called the parallelogram rule, where if you, let's say for whatever reason, it's hard for you to find the resultant vector, you could actually take the original two vectors that you were adding together and finish out a parallelogram. So like from this upper left-hand corner here, the end of the end point here of vector v, you could just kind of go copy what vector u would do. So down 2 to the right 3. And then you could do the same thing kind of from the tip of vector u. You could, or the head, I should say, of vector u. You could copy vector v by going to the left one and up 5. And notice you get this adorable little parallelogram. So vector v is parallel to this little part. And vector u, I'll just use little parallel symbols from geometry. Vector u is parallel to this guy over here. And then the resultant vector is the diagonal of that parallelogram. So that's also called the parallelogram rule. So kind of fun for resultant vectors. There we go. All right, my friends, I think this is a fine place to stop for part 1, and then I will have, let's see, looks like 3 examples for part 2.